everyone, and welcome to Module 8. In Module 8, we'll be talking about Chapter 8, which is on memory, and Chapter 9, which is on thinking and intelligence. So you'll see that I've left out some sections of both chapters just for the sake of trying to get through all the material we need to get through in this semester. So these really are the only sections I'm going to be covering from these two chapters. So make sure when you do your Revel reading, you're only reading those. Of course, you're more than welcome to read the other sections if they interest you. So let's start by just talking a little bit about what memory is, talk about some of the misconceptions about memory. But before we even get there, I want to talk about why it's important that we forget things. I think most of us just kind of take for granted what memory is. We just kind of hope that our memory works when it needs to work, and we don't really put a lot of thought into the actual process behind memory. So first, it's important for you to know that forgetting is actually adaptive. I know it probably doesn't feel adaptive if you're ever taking a test or a quiz and you forget something really important related to the material. That probably feels pretty maladaptive. But what I mean when I say that forgetting is adaptive is, generally speaking, if we were to remember every single thing that ever happened to us, that would actually make our memory process so cumbersome and the content of our memory so overwhelming that we wouldn't be able to do anything with it. So in order for our memory to be efficient and work well, we actually have to forget things. So when I say memory, what I'm talking about is the capacity to retain and retrieve information, and basically any of the structures that account for our ability to do that. So within memory, there's a lot of different processes, and there's a lot of different types of memory that we need to consider. The first is the distinction between explicit and implicit. Explicit memory is any conscious or intentional recollection of an event or item of information. So what I mean is the person is purposely or intentionally remembering and retrieving information about something that's happened to them or something that they know. And so it's really easy to measure explicit because it is conscious, meaning we can directly ask the person about it. So the two main ways we do this are recall and recognition. Both of these are things you're actually really familiar with if you've ever taken a test. So by recall, what we mean is we're asking the person with very little prompt or very little information to recall what they know about the thing. So that might be something like a fill in the blank. So if I were to just give you a bunch of definitions and asked you to write in what term was being defined, but I didn't provide you with a list of those terms, you're being asked to recall the term. Another example would be an essay question, where you're just prompted with a question or a topic to talk about, but then no other information is provided. So you're being asked to recall it, again, with very little content, and it displays a level of understanding or comprehension. So that type of question is harder than recognition because in a recognition measure, you're asking the person to recognize something, meaning you're giving them some information. So it might be a list of terms that I ask you to match with the definitions. If that's the case, that's recognition because all you're being asked to do is recognize which of the provided terms matches one of the provided definitions. So that's an easier type of test. But again, both of those measures are relatively easy to design because all you have to do is determine whether the person consciously knows something. Implicit, on the other hand, is harder to measure because it's actual unconscious retention. The person often doesn't know that they learned the thing. And we'll talk about more examples of that later, but one example of a way you can measure it is through priming. So what you do is you see whether the person has been primed to respond in a particular way. So again, this can be really hard because the person doesn't even consciously know they've learned whatever thing you're assessing. So if you give somebody a list of words, and then later you give them a list of partial words, what we find is they tend to fill in the partial words with the words they've already seen. So if I gave somebody a list of words and one of the words was tour, T-O-U-R, and then on the list of partial words, I just listed the letters O-U, chances are if they've implicitly remembered or implicitly learned that word, they're going to be more likely to finish it by adding a T and an R to make the word tour. So as I said, memory is super complex, and throughout the decades, psychologists have really disagreed about how to talk about memory and how to model memory. And so the three-box model is one of the more commonly used, but essentially most models of memory are talking about it as an information processing, system where the person encodes information, stores the information, and then is asked to retrieve the information later. But this is one particular model that gets a little bit more specific than that. And so it's based on this idea that you get information from your environment and then you hold it in this kind of this storage vessel in a kind of abstract way until you can determine what you want to do with it. And we're talking about the sensory register. So the sensory register is the entryway to our memory system. It has an extremely large capacity, can hold a lot of things, and it holds those things really accurately. So that's the kind of pros, the good things. The con is that we hold that information for a very brief period of time. So essentially think of it as you're navigating your everyday life, you have an experience, you take in a lot of information from that experience, and then your memory system determines what's important and should be kept and what needs to be dumped. Most of that information is going to only be held for 1 or 2 seconds. If it's visual information, it's actually held for even less, about half a second. So the system determines what can be dumped and then will determine what needs to be kept. The stuff that needs to be kept will be transferred to what we call short-term memory. More contemporary, more current scholars often use the word working memory because it just indicates that this is an active system. Okay, so I kind of like the term working memory because again, it's this idea that you're kind of holding the information, using it, manipulating it. It does, I think, better communicate that it is working, it's active. But the 3-box model tends to say short-term memory, same thing. Essentially, you're able to hold it for longer than the sensory register, but the short-term memory system is going to be less accurate. You're already going to start to lose some information, and this is also relatively brief, like 30 seconds, maybe a little longer if you're rehearsing the information, meaning, for example, repeating a phone number over and over. If you repeat the number over and over, you'll be able to keep it longer than 30 seconds. But that's not really a viable long-term solution. Instead, if it's something you want to keep forever, and I kind of put air quotes around forever, the idea is that these memories are relatively permanent once they get to long-term memory, but we will see some decay, for example, that even long-term memories will be lost with time, or they could be replaced with new memories. So I'm kind of air quoting permanent or forever. But essentially, if something is deemed important or something you want to keep around longer than just a few seconds or minutes, it's going to be transferred from short-term to long-term memory, which has unlimited capacity, and the information tends to be organized and indexed in a way you could use it. So for example, we have semantic categories where we group kind of like similarly themed things so that we can more easily or accurately retrieve it in the future. So this is the 3-box model. So it is one of the leading models of memory, but it also has some flaws. For example, this suggests a very linear process. So, information happens, it goes to the sensory register, short-term to long-term, and it's just happening in this order and that you're dealing with one piece of information at a time. I'm hoping you're picking up on the fact that memory is probably not that simplistic. We know that as we're experiencing events, a lot of different things are happening, different forms of sensory information's coming in. So chances are it's going to be a little bit more dynamic than this. So that's why your book talks about the parallel distributed processing model, which proposes more of this idea that memory is happening in layers and there's different components that are interacting with different aspects. And so it just takes this idea, makes it slightly more complex. Before we move on to talking about other aspects of memory, I want to pause and return back to something we talked about a few minutes ago. So again, when we're talking about long-term memory, there's lots of different types of memory. And so let's return to this idea of implicit versus explicit. So by explicit, what I mean is something like facts and events. And so there's 2 subtypes your book talks about. Semantic, which would be the facts and the rules. Episodic would be more of the personally experienced events. And so that's what we would call like a declarative memory. It's a little bit more kind of intentional or conscious. So for example, I could tell you a semantic memory that involves the rules of how to play disc golf. If you've ever heard of disc golf or played it, so I could tell you how to score. I could maybe describe one of my favorite courses where I play disc golf in Richmond. So that's more of a semantic kind of facts and rules declarative memory. Episodic memory, on the other hand, is more of like a personal experience. So an episodic memory related to disc golf might be me telling you about the time that I was throwing a disc and accidentally hit a tree right in front of me, and the disc ricocheted and hit me in the face. Everybody thought it was hilarious. I thought it was painful. So that's more episodic. It's a personal experience. So these are very different from implicit memory, which relates back to something we talked about very recently when we talked about classical conditioning. These are memories that are more kind of unconsciously acquired. We aren't intentionally learning them. We might not even necessarily know we learned them. And so this, again, classical conditioning, as I just talked about priming, another would be procedural. So essentially the how to do something. So I don't know about you, but when I drive, that is mostly an implicit memory. I don't sit there and think about, first I turn the car on, then I back down the driveway. I'm going to turn left here, right? Most of the time, unless it's somewhere I've never been before and I'm very carefully paying attention to what's happening, I just kind of arrive at my location with no real memory and very little effort in terms of how I got there. So that's a procedural memory or an implicit memory. So again, this is just to kind of highlight and get you thinking about the idea that memory is very complex and involves lots of different components. But there are things we can do to remember better. The first thing that we almost always forget is effortful encoding. The first step to memory is encoding that information. And so students that come to me and ask for help for studying or how they can do better in classes, regardless of the class, I actually talk to them about this very information. So memory and cognitive psychology in general can help us learn more effectively. And the first step is be more mindful and aware of how you're encoding the information. So you shouldn't just kind of passively sit there and hope you get the information into your brain somehow. You need to be thinking about how you're putting it in your brain. That also involves the processing, right? So in terms of how we process, deep processing is going to be better than just the kind of haphazard processing, right? Rather than just kind of, again, memorizing facts, we need to be thinking about how the material we're learning relates to each other or relates to other things we've learned. Elaborative rehearsal, which is where we are actually practicing grouping the information and thinking through how we can remember it. So again, rather than just kind of rote memorization, practicing and thinking through, like mnemonic devices, for example, and how to use those mnemonic devices. Active studying. So again, rather than just reading your Revel book over and over and over and over, read it, close the tab, and then actually get out a pen and write down some things and see what you could remember and try to create like maps where you're connecting content to different sections that we've talked about or different chapters, because I hope you're starting to see prior information's coming up in the newer chapters. So trying to connect the information can help you learn it. And then the other thing that people forget, again, effortful encoding is important. Retrieval practice. Students do not practice retrieving the information. They get stuck in this kind of like rote memorization stage and then never actually practice pulling the information out of their memory. That can be very important as well. So essentially, the way that we remember things is much more complicated than most people realize. We almost always just kind of colloquially talk about memory as if it's a tape recorder or a video camera. That is not true. It's highly selective, meaning we only remember some things. It's reconstructive, meaning that when we remember, we're actually pulling information from a lot of different sources. It just isn't perfectly a nugget of memory in our brain. So two related concepts. The first, source misattribution. Sometimes we forget where we learned things. So I know that I have a memory from Christmas morning when I was 2 years old where I broke my aunt's nose by running down the hall, jumping on the couch, and apparently I headbutted her. I have a memory of that. But the funny thing is it isn't my memory. It's because everyone in my family has told me over and over and over it happened. So through source misattribution, I'm misremembering, meaning I'm thinking I'm remembering it. In actuality, it's information I learned elsewhere. Confabulation is where you confuse an event that happened to somebody else by thinking it happened to you. So this happens when we hear about an event a lot in great detail, and it's something we can easily imagine happening. Essentially, we reconstruct our memories through lots of sources of information, and through that reconstruction, a lot of mistakes can happen. Okay, so that's what I wanted to talk about with memory. I'm going to go on to part 2 and talk about intelligence.